We could give this a name called start tentacles or something like that. I didn't do that here, but we can. All right. So what I want to do there is I want to only keep the bottom primitive. So the bottom primitive is already called 0 here. I guess you could theoretically still sort it to make sure that it's the 0th one. But in this case, let's just type blast and let's type 0 and then type delete non-selected. So we only keep the bottom one. Right, so this thing is what we're going to be copying our tentacles to. So if I go and watch on the second part, you can see I have these lines, but they're sort of pointing away from our thing. So how does that work? So let's first just make a copy to point. But I mean, we've done that before, right? So let's make a line. Let's put it in the Z direction. Let's copy it. Let's go our first view. Right, so this is obviously not what we want. We want them to more sort of point away from our thing, because if we template this, you see it's pointing downwards. So how did I solve that? All right, so what I did is, if you can see here, there's an add. So what an add does is create a point. So let's have a look over there. So there's a point, and that point has a position. And what we're doing is we're subtracting the position of every point here from this one, and then we get a vector pointing away from that thing. So let's do that. Let's create an add, and don't worry, this will become more clear once we do it. So put down a add. So an add will just create a point. So we have a point here. Let's move it up a little bit. So the higher we move it up, the more they will face inwards, and the lower it will be, the more they face outwards. I can demo it in a little bit. Let's make an attribute vol. Let's plug it in there, and let's plug the add in the second input. All right. So let's dive in there. So what do we want to do? We want to import a point attribute. So if you get something from the second input, you cannot bind it, because bind will automatically grab the first input. So bind is binding from the first input. If you want to import from another thing, or if you want to, for example, get an attribute from a primitive while you're running on points, you need to say import something. So you plug this into op input 2, so second input. And we want to import the position. And then what we want to do is we want to say subtract. We want to subtract our current position from our imported position. And then if you plug it into the normal, so let's have a look. So you can see right now, this is not really doing what we're after. You can see one of the points is sort of doing it. You can see only one over there, right? But the other ones are like, I'm just chilling, don't really wanna do that thing. So how can we say that we kind of want to do it for every point? So you see this thing has an input for every point number. The thing is, if we sort of put point number in it, what it will do is it will try to match up point numbers from our second input and our first input. So let's look at our point numbers. So you can see 0, 1, 2, 3, 4, 5, up until 49. Now let's look at the second input. And why doesn't it show the point numbers? I have no idea why it's not showing the point numbers, but it's 0.0. So spoiler alert. So it cannot match it up. It can only match it up for this point. Well, what we can do is there's something called a modulo function. Let's Google it. Modulo is a math operation. It's fine to remember. Blah, blah, blah. Too complicated. Let's just make one. So what it will do is it will sort of, if I, for example, say a modulo on the frame, and let's say modulo 10, then it will sort of repeat after 10 frames. So it will just keep going in a loop. If I put down a modulo on my point number, it will sort of repeat after it hits that one. So let's look at our normals, and now you can see it does work. So it will just repeat the import point after 0, it will just repeat. And so it will just modulo across all of the points. So if I disable that, it will only do it on this one, but this one will sort of loop through all of the points and then say, nope, match it with 0.0. Nope, match it with 0.0. So if I put this to 0, does it still work? Yeah, it also still works. If I put it to 2, it will probably not work anymore. Yeah, you can see now it sort of only does it after. If I put it to 3, you will see it sort of only does it for like every other one. If I put it to 5, so you can see you have some control over that, but let's just put it to 1. Okay, so we can also do this thing inside of, one more thing, we probably want to normalize this, this vector, because right now, like, let's say if I move this up super high, you can see these get super long. So if we say, maybe we want to normalize this, so normalize it from between 0 to 1, then it doesn't really matter. It will just always be a 0 to 1 vector. So that's that. So another thing, let's say we want to do this in a wrangle. It's actually easier to do this in a wrangle. We don't even need a modulo for that. So if let's plug in our geometry and then this thing in our second position. Okay, so what we want to do, we're going to create a placeholder vector called pos. We could again also call this cheese. It doesn't matter, it's just a placeholder name that we're using. And it's going to be, and we're going to import our point position from a second input. If we type point, so import a point. If we were to type prim, it would import primitive. If we were to type detail, it would import detail. So just how it works. So let's type point. We want to import for the second position, and counting inside of this starts at 0, and then so 0, 1, 2, 3. I'm not sure why they made that different inside of VOPs, because in VOPs it just starts with 1, 2, 3, 4, which is a little bit inconsistent. Again, but second input will be 1. So 0 will be the first input, 1 will be second input. What do we want to import? We want to import the position, and then what point do we want to reference? If you were to type at ptnum, then you would reference every single point. So that's what we got when we didn't do the modulo. Or I could say, I only want to reference 0.0. So then we're only referencing 0.0 for every point. All right, so now I can say that at normal, so at n, so if we want to be specific, type v at n, so vector at n, because again, it recognizes at n as being a vector because it's just it's just default for being a vector in Houdini, but you kind of want to be specific with stuff like this. So just make it a good habit. And then say that at position minus pos, and then you can see this works. And then I want to put this between brackets because maybe I want to normalize this. Again, order of operations brackets. So normalize. So again, if I were to type at ptnum here, tnum, ptnum, but you can see it only does it for the one thing, and here I can explicitly say to be 0. So now we get the same result on our wrangle, on our VOP. So again, you can see this is probably easier to do inside of a wrangle. So you can kind of see why a lot of people prefer wrangles. But again, you don't necessarily need wrangles inside of Houdini. It's just easier for some stuff. So use whatever you want. I'm not judging. So now you can see our copies are nicely pointing the way we want, and we can control it with our point over there. So maybe give this some names. So call it, I guess, just keep that one at, I have no idea what to call it. So I guess call this create normal. And maybe also call the wrangle like that. So it would create like that. All right, so again, I can either put the wrangle in here or the VOP. You can see it does exactly the same thing because inside the wrangle, it's just also a VOP just with a snippet. All right, so let's move along. All right, so one more thing that I did over here was put down a delete. Just put it 2 points. And then just by range. So select one of every two, and then you can see I left with a lot less copies. So I could, if I increase this, you will see it will become a little bit more. So just to have a little bit less tentacles going on. All right, so now we can move along to the more interesting part and do something with our with our like creating the movement. So you should already sort of know how to do this. I am using a different noise type in here called an anti-alias flow noise, but you could already have a go maybe and try this for yourself. And then before you watch the next video, and in the next video I will be building this, but you can already have a go at maybe trying for yourself how you could do this sort of to learn. And well, if you don't want to try it for yourself first, then I guess you could click to the next video and watch it over there.